Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 2.4. And we are going to obviously start with question 2 because we have covered question 1 in the previous lectures. And I would prefer if you would watch question 1 first and then come to this lectures, so that your concept would be clear and you would find it much more easier to understand. So for question 2, we have the question x squared plus 5x minus 14 is lesser than 0, and they have told us to solve this up. So this is really easy. We have been doing quadratic equations from the starting. So x squared, um, and we are going to take the common of 14. So 7 2s are 14, 2 1s are 2, and x squared plus 7x minus 2x minus 14 is lesser than 0. Factorize this: x as the common, x plus 7 minus 2 as the common, x plus 7 again. So it is lesser than 0, and x minus 2, x plus 7. We have two values for x. X is equals to -7 and x equals to +2. So the thing is, before we go on, I've discussed this clearly in the lecture in which I've recorded question 1, that whenever we solve these type of questions, we need to draw a mini graph with it, and I'll tell you why it helps us. So for example, we make a point from -7 about here to +2, and we make a parabola. This is approximation of the graph for this quadratic equation. So the thing is, what they've asked us are the values for this quadratic equation which are lesser than 0, meaning the negative x values. Whatever values are lesser than 0 are negative. So the negative x values in the parabola are obviously between the points -7 and +2, because that's the point after which the graph is going down. So we can say that whenever x is greater than -7, it is a negative value until it becomes comes up to 2. So it is after 2 it becomes a positive value as it goes up from the x-axis. And the reason why we have not told them that this is equals to lesser than greater than equals to 7 or lesser than equals to 2 is because they've not asked us the values for 0. -7 and 2 are the points where x is equals to where y is equals to 0. So they have not asked that. They have only asked the values which are lesser than 0, and we have stated these. For part B, it's quite similar. X squared plus x minus 6 is greater than equals to 0. Okay, again what we do is take the common of factors of 6. It's going to be 2 are 6, 2 1s are 2. So we are going to get x squared plus 3x minus 2x minus 6, x as the common, x plus 3 minus 2 as the common, again x plus 3 is greater than equals to 0. So x is x minus 2 and x plus 3, and thus we are going to get two values for x. X is either equals to, okay, let me use next part. So x is either equals to +2 or x equals to -3. So we have two values for x, and basically what the according to the graph, what this basically is -3 to +2. It's basically showing this type of parabola. Let me correct this, something like this. Okay, so the thing is, we have been asked to tell the values which are greater than and equals to 0 for this quadratic equation. So when is the graph greater than equals to 0? Well, equals to 0, for the equals to 0 part, we have -3 and 2, meaning we are going to add -3 and 2 in our equation. However, what are the parts which are positive? Well, if we say that if we go behind -3, for example -4, -5, and so on and so forth, we are going to get positive values. And if you go after +2, we are going to get positive values for 3, 4, and so on and so forth. The thing is, we can say that whenever x is lesser than -3 and equals to -3, because they've also asked the values which are 0, so it's going to be a positive value. And also when x is greater than equals to positive 2, we are going to have positive value for this curve. So that's basically what they are saying for this question. Okay, for part C, what we have is x squared minus 9x plus 20 is lesser than equals to 0. Before I start, let me just check one thing. Okay, so x squared minus 9x plus 20 is greater than equals to 0. Again, solve this. Now I'm going to use my calculator from now on because it's going to take lesser time. I hope you know how to solve quadratic equations. I've solved them many times. So now it's up to you. So again, I will use my calculator. So x for 1, negative 9 and positive 20. We are going to get x equals to 5 and x is equals to 4. So we have two values for x equals to 5 and x equals to 4, and what that basically means are the values which touch the x-axis. So 4 and 5, approximately something like this, it's going to go away. So what they've asked us are the values which are lesser than equals to 0. So meaning which are below the x-axis and which are at the x-axis. So at the x-axis we have the point 4 and 5, and between these 2 points are the coordinates which are lesser than 0. So we can say that whenever x is greater than equals to 4 and whenever it is lesser than equals to 5, and if it um, if it follows both of these conditions, the graph is going to have a value of negative or equals to 0. Okay, so that's basically it. Again, if you don't understand what I'm doing, the main concepts and all, I would suggest you take my previous lecture on question 1, and I have a great introduction for these type of questions in that lecture. Okay, so we had done till part. Which part had we done? Okay, I just forgot the part. Let me remember. Okay, we are about to do part D. Okay. So for part D, we have x squared plus 2x minus 48 is greater than 0. Again, solve this up. I'm going to use my calculator again. So 1, positive 2, and negative 48. We are going to get two values for x equals to 6 and x equals to negative 8. If we visualize with a small graph of some sort, negative 8 to positive 6, something like that, we make this graph, and they've asked us the values which are greater than 0 but not equals to 0. So negative 8 and 6 are not to be the part of their requirement. So if we see, if we go before negative 8, the graph is going to get a positive value, and if we go after positive 6, the graph is going to get a positive value, and the values between them are not going to be applicable for this equation, as well they are negative values as they're below the x-axis. So we are going to say whenever x is lesser than negative 8 and whenever x is greater than 6, we are going to get the set of values which are going to fulfill the requirement for this equation. Okay, for part E, what we have is 2x squared minus x minus 15 is lesser than equals to 0. So what we are going to do is take the common. I'm going to solve this one with you guys. So 15 multiplied by 2 is going to be 30, and the reason why I'm going to solve this one with you guys is because it's going to have answer in decimals. So I think it's going to be easier for you if you understand this one. So 2 multiplied by 15, because we multiply with the coefficient of x squared, will the c value. So 3 ones are 3, 3 0 is 0, 5 2s are 10, and 2 1s are 2. Make 1 out of this. 3 2s are 6 and 5. So 2x squared minus 6x. By the way, if I've not mentioned it till now, I don't remember, but it's a trick that whatever value you get, okay, try to make the negative or the positive value, whatever it is, try to make the value first which has the same sign as the value you are going to break about. For example, you're breaking negative x, so try to bring negative 6 first. Okay, it's going to make the correct equation there. So 2x squared minus 6x, and then we are going to add positive 5x. Minus 15 is lesser than equal, yeah, it's lesser than equal to 0. Again, take the common, 2x as the common, x minus 3 are going to come in here, 5 is the common here, x minus 3 are going to come here. They are lesser than 0. So again, what we are going to do is 2x plus 5 and x minus 3. So for this one, 2x plus 5 is equal to 0, so that means 2x is equal to negative 5, and x is equal to negative 5 divided by 2, which is equal to negative 2.5. And for the other value, x is equal to positive 3. So if we draw a graph of some sort, something like this, negative 2.5 and positive 3, we're going to get something like this of a parabola. And they have asked us the values of this parabola which are lesser than and equals to 0, meaning 2.5 and 3 are added in the requirement. So what are the values which are lesser than 0? Well, they are the values between 2.5 and 3, because they are the values which are below the x-axis. So what we are going to say is x is actually greater than negative 2.5, and it's also equals to that, but it is lesser than equals to positive 3, and that is the thing that fulfills our requirement. For part E, for part F, what they've asked us is 5x squared plus 9x plus 4 is greater than 0. Again, solve this quadratic equation. Coefficient of x squared multiplied by the c value, 5 4s are 20, 2 1s are 2, 10, 2 5s are, and 5 1s are. Make something out of this which will make 9. So 2 2s are 4 and 5 plus 4. So 5x squared plus 5x plus 4x plus 4 is greater than 0. So 5 as the common, x squared plus, 5x as the common, my bad, 5x as the common, x plus 1 plus 4 as the common, x plus 1 is greater than 0. So we are going to get 5x plus 4 and x plus 1. So if we solve this, 5x equals to negative 4, and x is equal to negative 4 divided by 5, negative 4 divided by 5, and that is equals to negative 0.8. So negative 0.8, and for the other value, x is equals to negative 1. So these are the two values of x we have found out. Now what we're going to do is visualize this with a graph. We make a graph, it's going to be negative 1 is somewhere like here, if we assume it, and negative 0.8 is somewhere like here. And if we draw a parabola for this points, they've asked us the value which are greater than 0, but they've also told us that those values should not be equals to 0. So negative 1 and 0.8 are out of this equation for now, and whenever we go before negative 1, meaning the values lower than negative 1, we are going to get positive values, and the values which are greater than 0.8 are going to give us positive values till infinity, and whatever are in between are going to give us negative values. So we can say that whenever x is lesser than negative 1, it's going to have positive values, and whenever x is greater than 0.8, it's going to have positive values. So that's basically it. This is question number 2. Proceeding on to question number 3. For question number 3, part A, we have x squared is greater than 18 minus 3x. Okay, again solve this up. X squared minus positive 3x minus 18 is greater than 0. Again solve this quadratic equation with the calculator. Positive 1, positive 3, and negative 18. So we are going to get two values for x equals to 3 and x equals to negative 6. Again, a small graph to visualize. Negative 6 around here and 3 around here. And if you draw a parabola, they have asked us the values which are lesser than 0, meaning the points which are below the x-axis. And well, the graph is below the x-axis between the points -6 and 3, with -6 and 3 excluded because they are at the point y is equal to 0 and they have not asked the values of 0. So we are going to say that whenever x is greater than -6 and whenever it is lesser than 3, and whenever it's between these 2 points, actually it's going to have a negative value, which means the values which are lesser than 0. So that's it. For part B, we have 12x is lesser than x squared plus 35. Again, that's going to give me x squared plus 35 minus sorry, I'm going to add negative 12x first. Minus 12x plus 35 is actually, if that would have been a, so it's greater than 0. And for those of you who do not know what I've done, well, I've basically done this. If you 0 is greater than 0 is lesser than x squared plus 35 minus 12x, and what I've done is rearrange these values, and well, I already knew that this is greater than 0, so I find it easier to put my equation on the left hand side, so I just switch the values up along with the sign. Okay, that's what I did. So what I'm going to do now is again input my values into the calculator: 1, -12 and positive 35. So that's going to give us x is equals to 7 and x is equals to 5. So these are the two values. We draw a small graph from 5 till 7, something like this. It's going to come and go like this. And what they've asked us the values which are greater than 0. So that means the values which are not below the x-axis, however they are above the x-axis. So whenever we go below positive 5, meaning the values which are lesser than 5, we're going to get positive values. So x is less than 5. And whenever we are going to go above -7, or you can say whenever we go after -7, or you can say that whatever values are greater than 7 are going to have positive values for the graph. So x is greater than 7. So these are the two conditions for which this graph is going to be positive. Okay, this was part B. Proceeding on to part C. For part C, what they've asked us is x multiplied by 3 minus 2x is lesser than equals to 1. So again, open this up. It's really simple. 3x minus 2x squared is lesser than equals to 1, and on the other side, negative 2x squared plus 3x, I'm going to rearrange this, minus 1 is lesser than equals to 0. So the thing is, for those of you who do not know the rules of inequalities till now, well, there's one rule that whenever you divide both sides by negative sign, you are going to get to change the side or the direction of the face, whatever you may call this, of the inequality or the face of the inequality. So the thing is, what basically happens is, for example, I want for now that the coefficient of x squared should be positive, and that's why I'm going to take the negative as the common. So negative 2x squared minus 3x plus 1 is lesser than equals to 0. And what do I do to remove this value from here? I take this on the other side and it's going to be multiplied by 0. However, basically what happens is I divide this by negative and I divide this by negative. Okay, and this negative sign and this negative sign will get cancelled. However, the other negative sign which I had put on the other side to balance both the equations will be divided by 0, and it will become essentially 0. However, if I would have divided by something like 3 divided by -1, it would have become -3 in the end. So that's basically what happens. We divide both sides by a negative sign, and we get, so 2x squared minus 3x plus 1. However, when we divide both sides by negative, in the case of inequalities, we change the direction of the inequality. So in this case it was lesser than equals to 0, but now what it will become is that it will become greater than equals to 0, and that's one of the rules for inequalities. Now we solve this quadratic equation. I'm going to use my calculator. 2, -3 and +1. That's going to give me +1 and 0.5. So x equals to 1 and x equals to 0.5. So we have two values. We draw a basic graph for visualization from 0.5 till 1, something like that. We make a parabola, and what they've asked us the values which are greater than 0, not the first value equation which has been in the question, but the updated one. We always do what is in the update. You don't use Windows 2 or something like that. I don't know even what was Windows 2. Well, less people use Windows 7, however. um, just leave it. So x equals to 0.5 till 1. So what they've asked us are the values which are greater than equals to 0. So whenever we go below, or whenever we go to the values which are lesser than 0.5, we are going to get a positive value, as you can see. Whenever we go above +1, we are going to get positive values. So that's going to be something like, whenever x is lesser than 0.5 and whenever x is greater than 1, we are going to satisfy the values which are in the equation. However, they have also asked us the values which are equals to 0, as you can see here, greater than equals to. So we are going to add equals to sign, because 0.5 and 1 are equals to 0. So that's it for part C. Let me erase the board so that we can do the rest of the parts. Something like this. Just it. Okay, for part D, we have x squared plus 4x is lesser than 3 multiplied by x plus 2. Again, simplify this up. X squared plus 4x is lesser than 3x plus 3 2s are 6. X squared plus 4x minus 3x minus 6 is lesser than 0. X squared plus 4x minus 3 is plus x minus 6 is lesser than 0. Okay, I'm using my calculator again. +1 again, and -6. That's going to give me two values, x equals to 2 and x is equals to -3. Let me recheck if I've done something wrong or not. Yeah, I've done everything right. So again, a small graph to visualize. -3 is somewhere like here and +2 here, and this is our parabola. What they've asked us the values which are lesser than 0. So that means the values which are below the x-axis, and the values which are below the x-axis are trapped between the point -2 and -3 and +2. So we can say whenever x is greater than -3 but it is lesser than +2, it's going to satisfy the equation in part D, which is x squared plus 4x is lesser than 3 multiplied by x plus 2, or whatever. It's going to satisfy this quadratic equation. Okay, for part for part E, x plus 3 multiplied by 1 minus x is lesser than x minus 1. So that's basically going to be x multiplied by 1 minus x. I don't know if you know this technique, but if we have something like x plus 3 multiplied by 1 minus x and we do not have any identities to solve this, we multiply every part of one equation with the other. So x multiplied by 1 minus x plus 3 multiplied by 1 minus x, and then we are going to solve this and it's going to be simplified. And for example, just for your information, if you would have something like x squared plus 3x plus 2 multiplied by x squared plus 2x plus 15, you would have done something like this. So x squared multiplied by x squared plus 2x plus 15 plus 3x multiplied by x squared plus 2x plus 15 and plus 2 multiplied by x squared plus 2x plus 15, and you get my point. Okay, and that's how you would have done that. I don't know any other method. If someone does know, please do share that in the comments. I would be happy to know. So again, what were we going for? Yeah, so x minus x squared plus 3 minus 3x is lesser than x minus 1, and then that's going to give us negative x squared minus 3x plus x plus 3 minus x again from the other side plus 1 is lesser than 0, and this positive and negative x are going to be cut down. We are going to get something like negative x squared minus 3x plus 4 is lesser than 0. Again, take the negative as the common. We are going to get x squared plus 3x minus 4, and what we do, as we are going to as we have divided both sides by negative, we are going to change the direction of the inequality, which is going to become make it greater than 0. And as 0 divided by negative 1 is going to be essentially 0, there's not going to be any change for the other part of the equation, other side of the equation, sorry. So again, we draw a small graph to visualize and make our life easier. Oh, before we do that, we find the values. So x squared plus 3x minus 4, that's going to give us 1, positive 3, and negative 4. That is equals to 1 and negative 4. So x equals to 1 and x equals to negative 4. So between negative 4 and 0.1, you're going to get a parabola like this. This is not accurate, it's just an approximation. Again, so what we do now is find the values which are greater than 0. So what are the values which are greater than 0? Well, if we go for the values which are lesser than negative 4, we are going to get positive values, and when we go for the values which are greater than positive 1, we are going to get positive values, and whatever values are in between these are negative. So we can say that x is actually lesser than negative 4, but it is greater than positive 1, and when it is something like this, it's going to fulfill the requirements for part E. Okay, for part F, let's go for there. Let me check if this is correct or not. For part E, yes, this is correct. Okay, for part F, what we have is 4x plus 3 multiplied by 3x minus 1 is greater is lesser than 2x multiplied by x plus 3. Again, simplify this up real quick. Oh, again, another method for this one was first the FOIL method, by the way. Before I start, FOIL method, I've used this in my previous lecture. I was just using that method for, you know, versatility of knowing things. However, this FOIL method can't be used for multiplying two quadratic equations. For example, something like 2x squared plus 3x multiplied by 3x plus 2 multiplied by 3x plus 16, something like this. It's not going to be used from the FOIL method. It's something else. Again, if somebody knows any method like this, please do tell in the comments. I would like to know. So for the FOIL method, multiply the first of these two brackets. First is going to be 4 3s are 12 x squared. First outer is going to be negative 4x. Inner is going to be positive 3 3s is 9x. And last is negative 3. And this is lesser than 2x multiplied by x is 2x squared plus 3 2s are 6x. Simplify this. 12x squared minus 2x squared minus 4x plus 9x is going to be positive 5x. Minus 6x and minus 3 is lesser than 0. So that's going to be 10x squared plus 5x minus 6x is going to be negative x minus 3 is greater than 0, is lesser than 0. Again, if you solve this up, two values for x are going to be negative 1 and negative 3. That's going to give us two values, which is 0.6 and negative 0.5. So x is equals to 0.6 and negative 0.5. If we visualize this on our graph is going to be something like negative 0.5 here and negative 0.6 here. Again, this is just a rough approximation. This is a parabola, and what we are going to do is tell the values which are again lesser than 0, meaning the points which are between 0.5 and 0.6, sorry, negative 0.5 and 0.6. However, we are not going to add negative 0.5 and 0.6 as the values because they have not asked for the values which are equals to 0. So when we say that whenever x is greater than negative 0.5 but it is lesser than positive 0.6, we are going to get the values which are lesser than 0, or you can say the values which are negative. So that's it. This is it for today. I'm in a hurry for now, otherwise I would have solved the rest of the questions. I'll meet you in the next lecture, and in that lecture we will hopefully complete this exercise and proceed on to exercise 2.4. Good luck till then, and I'll meet you in the next lecture. Thank you.